So is Thophos a Marvel villain?
It's Thomas.
I know.
I did it once, but then it came back like this, and I have absolutely no idea how to change it permanently. But once you've made the alias in your head, you know who I am, and
I don't know. I think it works as a character from the Marvel universe.
right, so even better.
Trying to think like what would the character's motivation be to fly around the universe delivering cryptographic evidence of the integrity of environments?
I don't know. What kind of environments are we talking about here?
These spaceships.
Spaceships, okay.
My gosh, Mike can't unmute himself. I feel like this is going to be an extra fun meeting. Sort of triggering things, can we say? I don't think confidential computing really needs attestation.
Boom. Zoom collapses.
If only somebody would write a book on this topic.
Mike, maybe you can start your video and do some, interpretative dance or.
Are other people having problems with their audio? It does look like we got a lot of muted people and no cameras.
Test 1, 2, 3.
I can hear you, Greg. Usama, how you doing?
Hello, do you hear me?
I can hear
Yes.
you, Usama.
Okay, so apparently that should be only with mic.
See if I can help Mike. I don't think I've got any special privileges, though.
Is there anyone who is the meeting host? Maybe he can help him.
Right.
Reboot.
Mike's going to the reboot.
Yeah.
I won't even ask what operating system.
You better, Greg.
Yeah, most of the problems can be solved by reboot just.
Let's give it a couple of minutes for Mike to reboot. Be back with us.
And I unfortunately will have to drop off pretty early on, but I wanted to at least check in at the beginning here.
And Mike is gone again. Should we start or I don't know? Yeah, right. Okay. Welcome, welcome. Today's agenda has Usama with 2 items. One small one, he's asking a question whether we want to conclude the formal spec project that he's been driving in the last 10 months. Skipping the AMD part, he's done work with the ARM architecture, the Intel architecture. There was AMD in scope initially, but apparently there's a separate team in Zagreb that is dealing with that, and it seems like duplication of effort that is not worth it. So I don't know what other things, but I would be happy with closing this project now with what the deliverables are, which if you go to the Forma Specti repo, you will find the ProVerif models for both CCA and TDX, both authored by Usama, and the CCA one was also co-authored by Shale. So I think it's been a pretty successful thing, at least from my point of view, having been summoned by Usama to collaborate with him on formalizing the CCA architecture. It was an excellent experience. But I will let Usama talk about this. And
Yeah, I think, Thomas, thanks. I think you pretty much said everything that I would have said. So just to maybe quickly recap, I'm sharing the screen. So we had, this was the proposal that we had back in January last year. So we had in the proposal like 3 main items, which were Intel TDX, ARM CCA, AMD SAV SNP. And as Thomas has mentioned, we have successfully completed the 2 of them. For third, there are 2 issues. Number one, we have, like, I met some people from AMD at OCP last year. I invited them. They never joined the meetings of CCC SIG somehow. So we don't have any expertise available at hand. Also, University of Zagreb are far ahead of us. So Professor Ante Derek has done a lot of work in that domain. And I believe that there is not much value doing the same thing again. So that would be, we are discussing how do we collaborate, and yeah, so both the parts that were in scope, that is provisioning phase, initialization phase, attestation protocol phases, so all of them are available at this repo. You can have a look, and if you have any suggestions or any comments, you are most welcome. We can have a look if you want to review. Maybe the SIG wants to review for, let's say, 2 weeks. I mean, we are not in hurry just to declare it complete today. So if you want, you can have a look for 2 weeks and go through them, run them, running the automatic proofs. All the instructions are here. You need to install ProVerif and run like this, and then you can get traces in this way. And there are a number of slides. It has been successfully presented at a number of occasions and appreciated at a lot of places. And finally, yeah, as Thomas mentioned, yeah, we had Shale contributing in the ARM CCA part as well. I would like to thank him for that. And also we would like to thank the 3 of the people. This is the one who is working on AMD SAV. He offered us good feedback on the work. And also from Scontain, Scone team, Nikolaus, who works with the attestation part, he was reviewing the stuff and gave very good suggestions. And from Intel, Jivan Yao was very helpful, and he gave us a lot of the puzzles that we couldn't solve ourselves. So yeah, thanks a lot to all of them. Yeah, I think that's all I would like to say here. So if you have any comments, anything to suggestions, or if you think that something can be done as an extension of this, your comments will be more than welcome.
I think projects always go through versions, so I mean, you can always call this like the 1.0, and then if AMD or other hardware vendors also want to get involved in this, then that can be a a second version.
Mhm.
For the parts that are complete here, are they, from your opinion, complete, or you weren't able to fill certain holes because you couldn't get contacts, or it's actually good?
So is your question specific to AMD, or is it about in
No,
general?
for TDX and CCA,
No,
you're comfortable with the output that
yeah.
you have here, or you need help that never showed up?
No. So for Intel TDX and ARM CCA, sorry for the confusion. So for here, I think as far as I am concerned, I am quite happy with the to the level of detail that we have gone to. I mean, it's a lot of detail. It's 20 pages and it's double column format IEEE, and so I mean, we have put in all the details that we could after all the discussions with ARM and Intel. So I believe nobody else has any more discussions, which any more details that are publicly available at least. So there would be definitely some details that might be internal, but all that is available publicly, even though we have gone beyond what is publicly stated. So also from the Verizon part, we have taken all these, other than the ARM specifications, we have extended these artifacts, the verifier part and so on. So to my knowledge, at least whatever we had, we have put in there. So from my perspective, I would call these two parts at least complete. And AMD, yeah, so that is still a question that whether we proceed, and then the question is whether that would be valuable to, of course, like we can proceed, but the question is how valuable that would be compared to what already exists or is in progress at the University of Saleh. And they are just to add quickly, so they are very good people. I mean, I trust them that they will do very good work. This, and also Marco Horvath is involved in this work. And they gave recently in December, they gave a presentation at our workshop about the recent work they have, the state of the project. And I'm also quite happy with the way they are proceeding the work. So yeah.
So I was just flipping through the slides that you have on the from December of 2023, and I see it says formal proof of insecurity of Intel's claimed TCB. I feel like you've mentioned that in the past, and I was hoping that with GWEN and anyway, with GWEN or anybody else that contributed, you were able to close gaps. Is that still something that you feel is a conclusion of this investigation?
Yeah, I think the thing that you are referring to is this one. So basically that was related to the TCB claimed in the white paper of Intel, and it's
was this the graphic where it showed that like these are the things within the TCB, but it didn't include the provisioning?
Yeah, that's correct. So it was fixed in the latest specifications.
Okay. Maybe we can think about the wording of that, but I don't need to drag the meeting down with that. I just want to make sure that we convey something that's meaningful there.
Yeah, I mean, this is like formally we if somebody said that it's trusted, so definitely that's a claim. So I don't see anything wrong with the wording here, but I'm happy to discuss offline if you think still.
Yeah, so I think somebody from me or somebody else should follow up on that. But again, we don't need to drag this meeting down.
Sure.
Look, I have a couple of questions for Usama, maybe if you want to.
Yeah, sure.
Okay. One was about your plans, right? So Dan is talking about version 1.1 or 1 or 2. So you're thinking of bringing these artifacts forward in some way yourself. And the other thing that I wanted to ask is whether anyone else has shown up and said, okay, we're gonna use this for A and B and whatever other projects.
So I'm not sure if it was for the second part. Definitely there is a plan for the project that we can use, and our team consisting of Jivan Yao and Christian, I forgot the last name, so both from Intel. We had a lot of discussions with them, and what they are doing is basically integration of VTPM solution for Intel TDX. So they are using the same artifacts for Intel TDX, and what they are doing is basically integrating, or basically I should say, like what we are doing. I'm also a part of this. We had a lot of discussions, and then we had a bit of a gap in between due to the other papers that we had. So the idea there is that in the artifacts of TDX, they will integrate the VTPM part, and then it's a combination of the two. So this part from the TDX will be used mostly as it is. The new thing that's required there was local attestation between the trust domains. That's one thing. And another thing was that instead of the TLS, they were using like SPDM. So these are the two things that required. So SPDM needs to be formalized still. So this is one part that's used here. And for ARM CCA, we are planning that in the third project or the second project, attested TLS, the attester that we will use is basically this one for ARM CCA for the verification. We need to do some, we need to have something in order to take these claims and put in as a specific TEE. So far, we have just generic that I will present in a moment about the artifact that we have still taken. But then the plan is that we not only do this hypothetically, we also then extend it to some specific architecture. That is, then we take these artifacts and then see how it works with the whole complete formal proof for a specific artifact, specific architecture.
Thank
So,
you. Yeah, this one I
answer
was aware
your-
of the specific project, but I wanted to understand whether there were other integrations ongoing. But thank you very much.
So otherwise, I am not aware of any. So there was one lady from some university from the US, I forgot. So she contacted me regarding this, that she had some idea, but she didn't follow up on that. So I'm not sure if she made some progress on this. So she wanted to do something with Intel TDX. So I think Hasini, something like this. Yeah. And other than that, I'm not aware of any usage, or nobody discussed with me so far that how it can be used.
Good. Okay,
Of
thank
course,
you.
if someone has ideas, they are more than welcome to. I'm happy to extend it to your needs if there is some application specific.
Good. So are we good with your suggestion of leaving this 2 weeks window for review? And then, after
Right.
that, declare success. So basically at the next tick,
Sure,
Yes.
sure. That's fine. Yeah.
Okay, cool. So
Okay.
you have another item, formalization of RATLS. If you
Yeah.
want-
Sure. So then I hope you still see you see the slides now. I'm not sure if I shared the full screen or.
No, we see a GitHub page.
Oh, okay. So then I need to share again. Sorry. Okay. Right. So yeah. So this is basically now switching from project 1 to the, let's say, the intersection of the project 2 and 3. Somewhere in between, I will clarify what does this mean. And also thanks to these people who have contributed to this, Arto, Hannes, and Thomas. And the reason I called it a roller coaster ride is maybe will be more clear as we proceed with this. So then I will just skip that and move to agenda. The first thing is, I will just quickly recap is TLS, going a little bit into the problems of TLS. And then remote attestation, as you all know, just a quick recap of terminology that I will then use in the rest of the presentation, sorry. And then combining the two, that was the basic goal of the project, attested TLS in a secure way. And that's where we have formal proof was required. And for the formal proof, I described three main parts, which are the key schedule of TLS, the protocol of attested TLS, and then the properties. How to say, like the formally how do we express it? What do we want to verify? And then I will finally summarize. And feel free to stop me at any point of time when you have any question. So I will not be monitoring the chat. So please, if there is any question, Thomas, please let me know.
Of course, I'm monitoring the participants.
Great, thanks. So very high level idea, data in transit. We know data in transit and data in use, two main things. And TLS is used in a lot of daily life usage. And conceptually or technically, it has two main parts, namely the handshake protocol and the record protocol. And I will mostly discuss about handshake protocol because that's the most complex part, and with complex parts come most of the vulnerabilities as well. And so from a technical perspective, we can, although the RFC describes like 3 parts, so I would prefer to have it like 2 parts, which are cryptographic, namely the server parameters. I think somehow it is what they call it, the third part, which is not cryptographic. It's just a part of the first part, or I put it as 2 parts cryptographically, which are important. So the first one is unauthenticated key exchange, which is happening within the client hello, server hello, as well as the encrypted extensions, which is when some of the extensions are required to be kept safe from attackers. So this is the first message, which is encrypted. And it also includes the parameter negotiation, which has function, which signature algorithm and so on. So they in these 2 messages, basically they are negotiating these things. Client proposes something and then server selects and so on. And then is the important part, which is important from RATLS perspective, the authentication, starting from the certificate and to the finished part for client finished, which includes the key confirmation, which is like this, or also called as proof of possession, that the server proves that it has the possession of this private key, which I name as private LTK, the long-term key. Standard TLS, we are not yet into attested TLS. So what standard TLS does is that we have a long-term key, and then it signs the log up to the certificate message